Hello, Algebra 3. I am going to go through the 1-5 lesson dealing with complex numbers. Our two essential questions are going to be, what is a complex number? And when do we need to simplify a complex number? Don't worry about writing those down now. We can get those written down at the end of the lesson here. So first of all, just a little review here. Real numbers are represented by a number line. Let me kind of fix that big blob there. By a number line. So think of a number line that looks like this. And we usually have 0 somewhere in the middle. And we got numbers left and right of it. We got fractions, we got decimals, we got positives and negatives. Alrighty. Real numbers are divided into kind of two major sets. We have the the rational numbers. Those are numbers that can be written as a fraction of integers. And we have irrational numbers. And again, a good example of an irrational number is pi, because that cannot be written as a fraction. It has a decimal that does not repeat and does not end. Okay? Now a key statement here is that every number is a real number if it's on the number line. So pi could be on our number line. It's a real number, but it's an irrational real. Moving on. Complex numbers. They're a bit complex. They have a real part, referred to as the A. They have an imaginary part. That's called the BI part. And the I is the imaginary unit. Okay? So complex numbers are complex because they're made up of two different types of numbers. So again, common one is 3 plus 2i. There's an example of one. Negative 5 minus I. That's another one. I is our imaginary. A lot of times I like to make my I with this kind of reverse J curl on it. And then we could have something like 1 minus 1/2 I root 7. So they can be pretty complex. They can have fractions, they can have radicals, they can have decimals. So complex numbers are a bit complex because of the fact that they have multiple parts to them. Moving on here. A pure imaginary part would be like I, negative 7i, root 7 times, I don't know why I'm loving the 7s this morning. So these are all examples of pure imaginary part. That's when the A, the real part, is 0, so there's no real part. Okay, let's get to writing some of these up in complex number form here. So the key basic fact about the imaginary unit is that I equals the square root of negative 1. And the second key fact that we're going to use is that I squared is negative 1. So we're going to use those facts here. So this really is the square root of negative 1 times the square root of 36. Square root of negative 1 is my I. Square root of 36 is a perfect square, so it's 6. So my final answer will be 6i. If we can do that a little quicker here, I can say, okay, I got the I for the negative inside the square root. Root 15 cannot be simplified, so we are done here. We normally like to have the I out front. Otherwise, if I write it like this, sometimes that I looks like it's in the square root, where in fact it's not. So don't get in the habit of writing it like that. Over here, again, let's do the quick. So I'm going to get I root 3 times I root 6 respectively here. I times I is I squared. Root 3 times root 6 is root 18. This becomes negative 1. This I can split into 9 and 2, but root them, so I get 3 times root 2. And so my final answer is negative 3 square roots of 2. And again, you could shorten that up a little bit if you'd like, but the main thing is to identify that these are imaginary parts, even though this final answer does not have any imaginary parts. Continuing here with simplifying, again, think of the real parts as like terms and imaginary parts as like terms. So here, I'm going to get this plus this gives me 15. These two give me plus 2i. So my final answer is 15 plus 2i. We like to put that real part first. I don't get too excited if it's 2i plus 15. Let's do number 7, because number 7 is like number 4. If you notice here, I got these two they look a lot alike, but one's minus and one's plus. We call these conjugates when we have a binomial with one plus and one minus. In the case of this one here, because it's got the I involved, these are called complex conjugates. We'll talk more about those in a moment here. So if I go ahead here and combine these two guys, that gives me 16. If I got negative 5i plus positive, that gives me 0. So when I add these conjugates, I just get plain old 16. That's kind of slick. Let's go ahead here, take a look at number 5. We have some foiling going on here, so I'm going to write FOIL. So again, that's first times first, outsides multiplied, insides multiplied, and last times last. So if I go first times first, I get 28. If I do my last, I get negative 7i. If I do my insides right here, I get plus 12i. And if I do last times last, I get negative 3i squared. But that I squared is really negative 1, so what I do is I just cross out the I squared and switch the sign on my 3. So now I have 28 and 3 for 31. I have minus 7i, 12i for plus 5i. So there's my final answer. Continuing here, again, I've got these conjugates. And if I do FOIL, I'm going to get, I'm going to get 8 times 8, 64. The last, plus 40i. My insides, or the outsides, then the insides, I get negative 40i. And if I do last, I get negative 25i squared. These cancel, and they will always cancel if we have conjugates. So we don't have to do FOIL. We can just do FL. And then here, that switches that to positive. So I end up with 64 plus 25. So it looks like a cool 89. So you will have worksheet problems that can allow you to practice these here. Continuing on, we talked about conjugates. And again, in this case, we're talking about complex conjugates. So make sure to add that. And that's going to be in the form a plus bi and a minus bi. So conjugates would be like 5 minus 3i and 5 plus 3i. So as long as we have the same pieces with a different operator in between them, we're fine. When we add them, going back to that one problem, that problem number 7 we had, we get a real number. And when we multiply them, we get a non-negative real number because of the fact that we're basically squaring A and squaring B. And we've already practiced those with This problem here was a complex conjugate 1. This one here is a complex conjugate 1. So we've already done a little bit of work here. Now, they want us to simplify this to a plus bi. We have one thing with complex numbers. They're not really allowed to be in the denominator. So the reason why we need those conjugates is right in this case here. I'm going to take this binomial and multiply over here by its conjugate to kind of clean it up, because I'll get a real number in the denominator. And what I do to the bottom, I need to do in the top as well to keep the expression equivalent. I'm going to go through and kind of set up 9, 8, 9, and 10. Here the conjugate is going to be negative I. So I'm going to multiply this by negative I. Over here, it's going to be the conjugate is going to be 3 minus I and 3 minus I here. So we focus on the denominator. The numerator can be whatever. So now let's go ahead here and take a look here. I'm going to distribute in the top here. So that's going to give me 3 plus 4i. In the bottom, I'm going to get 9. Remember, I only have to do FL. So first times first is 9. Last times last is a negative 16 I squared. But again, that I squared cancels and becomes positive. So I get this, and this is an okay answer. I can live with that. Over here, in the top, I get negative 8i. In the bottom, I get negative 1i squared. And this cancels, and I get 1 on the bottom, so I really get negative 8i. Down here, a little more complicated. I got a FOIL in the top. So first times first, 15. Last, negative 5i. Inside, plus 6i. Last, negative 2i squared. Switch, whack. And the bottom, I'm going to just use FL. 9 minus 1 I squared, so that goes here. So that's going to give me in the top 15 plus the 2 is 17 for my real. Here in the middle, I get plus 1i. In the bottom, I get 10. Okay. Now, number 11 here, they want us to list some of these powers of I here. So I know that this is negative 1 from previous. This, I'm going to multiply it by I, so negative 1i. If I take this and square it, I get 1. Okay. Now if I take this times I get 1i. If I multiply this by I get 1i squared, which gives me negative 1. So that's the same as this one here. And then if I take this and multiply it by I get negative I, or negative 1i. So they kind of repeat. Every 4 is like the previous 4. This one here, negative exponent, we get this. Now I'm going to take this guy and bring it over here. So I get 1 over 1, which equals 1. Alrighty. Almost done here. I guess I got those done, these done, that done. Okay. Last part here if two complex numbers are equal, then their real parts have to be equal, and then their imaginary parts have to be equal, or their coefficients here. So in here, finding x and y, here is my real part, and that's got to equal that. So off to the side, I'm going to say 2x plus y equals 1. Here is my imaginary coefficient. That's got to be the same as this guy. So 3 minus 5x equals negative 7. So now I got this is a system of equations. So this one's only got one variable, so I'm going to go ahead, subtract that 3 over. Negative 5x equals negative 10. So x has to equal 2. There's 1. I'm going to take this 2 and plug it in here. So I'm going to get 4 plus y equals 1. Subtract that 4 over. Y equals negative 3. So again, a little system once we kind of related the equal complex numbers, so to speak. Your assignment is to work on the worksheet 1.5. And here are the essential questions that I mentioned earlier. Well, there you go. This is lesson 1.5 for Algebra 3. Good luck with your assignment, and make sure to have your notes available as you work through your assignment as well here. So, see you soon. Bye.